So we know that beam splitters perform operations on light, and we kind of know what they look like, but what do they do exactly to light? So let's start with the classical picture, and then we'll move to the quantum picture later on. So in the classical picture, light is just a wave, and specifically it's a wave of electromagnetic radiation, and basically the height of this wave, we can think of the height of this wave as being the intensity, which relates to the energy of the wave. So here we have light that's entering into a beam splitter, with a beam splitter represented as this square that has kind of a diagonal line drawn through it. And the light is entering with some intensity A. And again, this A is just going to be kind of like this height of this wave, but specifically the intensity is the electric field magnitude of the light squared. But again, here we're thinking of it as energy and as this height of this light wave. And as this light wave enters into this cube, it's going to, some of this light will transmit and some of the light will reflect. So we can actually figure out how much of the light wave will transmit and how much of the light wave will reflect based on some property capital T of this beam splitter. So this capital T transmittance is going to tell us that the light wave, the intensity of the light wave that transmits will equal to this transmittance T times the initial intensity. And then the amount of the light wave that will reflect will just be 1 minus T times this intensity A. So we can see that this will conserve energy. As I mentioned earlier, the intensity of the light is related to the energy. So we have this expression, A equals 1 minus TA plus TA. This expression is always true. And this just means that our beam splitter is going to conserve energy and none of this light is somehow getting lost. So I want to add an important detail that I didn't mention on the previous slide, and that is that in general, for these beam splitters, there could be some phase shift when you transmit the light or when you reflect the light. So in this diagram here, I'm showing an example of reflected light that's been phase shifted, but you could also have this phase shift on the transmitted light. And all that this phase shift is it's just a small delay in the light that can cause interference effects.